what a segment is. It's granularity by time. So, in more recent versions of Druid, there's this thing called the Druid indexing service. It's kind of like a one-stop shopping for real-time and batch ingest. So instead of starting up a node that's dedicated just to real-time data ingest, you start up this thing called an overlord. And you're starting to see some of the Druid naming conventions. That thing is a little more flexible because instead of setting up a separate process to do real-time ingest, you just send a request to this overlord and it pops one up for you. There are a couple of batch ingest options available, and the indexing service can also do some segment management, which I'm not going to talk about. So this is what the indexing service architecture looks like. So there's this thing called an overlord, and you can have a number of middle managers. And so what basically happens is that, and we'll see the format in a few minutes here, requests to load data either real time on an ongoing basis or batch data all at once go into the overlord, and it puts in an entry into Zookeeper under a node, a physical node for Zookeeper, and this middle manager that you see down here knows it has to look up here at this task /mn1 to find out what it needs to do, and then it launches the task. So I love this naming convention, overlords, middle managers, and peons. I was just thinking, have you ever seen this where you work? So, now one thing that's interesting about this is that there's Druid, can be put in as large a cluster as you want, and most people start out with a single node, quote-unquote, cluster. There is a special property called the Druid indexer.runner.type. This thing defaults to local, and when it does, you don't need the middle manager at all. So that means the overlord, when it gets the request, launches these peon tasks directly. And that's what we're going to be doing tonight in my demo. So sorry if I'm blocking your view. So we'll be running in local mode. I've got an EC2 instance up and running, which we'll look at later. And basically you launch tasks by just posting this JSON payload to the overlord.
Hey, Wayne?
Yes.
So do you have that URL for the slides again for the remote viewers?
Yes. Kind of low tech, but this is on the slide deck, but it's not until like the last slide. So.
Okay, thank you.
Sure. Great. Perfect. So quickly, I'm going to go through the two types of ingest. There's a real-time ingest, and I should inform this by starting out saying what we're going to do is build a specification. It's in JSON. It will be posted to the overlord. Each type of spec has a type. This one is index_real-time. There are a number of out-of-the-box fire hoses, as they call them in Druid, and we're going to use Kafka tonight. So now, just quickly, these terms about granularity in Druid, which will become a little more obvious than I expect, but I should mention it now. There's an index granularity, so you're bringing in a bunch of tuples, and generally, you decide some of these are going to be metrics, and some of them are just going to be search dimensions. And basically what happens is anytime you get within your index granularity, say of a minute, anytime you have a tuple collision where everything is the same, except your metric fields, those will be aggregated. So that's what index granularity means. There's also a concept called an intermediate persist period, which is designed, I think, just to help restart in case you have a long-running task that crashes while you're building a segment. So an intermediate persist period is smaller than the segment granularity. And segment granularity is just how often do you want to push this to deep storage. So as soon as you start reading data in, it's available immediately by search on a real-time node. At some point, when the segment granularity is met, you want to push that out to deep storage. Now, practically, you need to have a little bit of wiggle room here, and that's what the window period is called. So basically what happens is, say I set my segment granularity to an hour, and then I set my window period to 10 minutes, and that basically says, okay, on the hour, I would push this segment out, but I want to wait in case there's some stragglers. And so if I say the window period's 10 minutes, that means I'm going to wait an additional 10 minutes to make sure no late data came in for that hour. And when that period ends, that's when the segment gets pushed out to deep storage. So if you have a segment granularity of an hour and a window period of 10 minutes, that means every hour at 10 minutes after the hour is a lot of stuff that goes on. Rejection policy, I just want to say that there are some demo configurations on the website where they have a rejection policy. I think it's server time. I can't remember what it is. You have to be kind of careful using these things out of the box, because I was running a test with one of these sample Kafka fire hose configurations, and I found that every hour, 10 minutes after the hour, my segment push would start and nothing went out. And the reason was the rejection policy that I blindly just copied from one of the examples was basically saying anything older than 10 minutes doesn't go in. Everything's older than 10 minutes. Sorry, Charlie. So you do have to be a little careful about that. I'll show you what my example is later. So the general rule is index granularity is the smallest granularity you have. There's intermediate persist periods. And the window period is usually the same as the intermediate persist period, but it's definitely less than segment granularity. At segment granularity time, all these intermediate persists are wrapped up into one segment that's pushed out. Now, for this particular, I'll talk a little bit more later, but I have to mention this right here. This property, Druid.indexer.task directory, this is typically /temp, and it puts it under another directory called persistent temp. One of the biggest problems I have with Druid is running out of space in /temp. And so typically what I try to do is change whatever properties I can anywhere to make sure that stuff doesn't go to /temp unless I have a really big /temp partition. I found a bug in this the other day, which was interesting. Basically, I believe when they added this property, somebody missed a couple of places in code that were supposed to use it. So if you override this and set it to anything other than /temp, some of your files will still go into /temp, and some of them will go into your other directory, and your incremental persist will fail because it can't find the files. Every 10 minutes it'll get a big stack trace. And in fact, there are a few other issues like that with temp directories in Druid. It's a best practice in Druid to not use /temp. You can set java.io.temp here, which if you set that property, auto-magically helps you when you say in the java.io.file stuff, create temp directory. That can be set by that property, and I think that's where some of the mistakes are in the code base right now. So say, for example, we're going to see this in a minute, but say, for example, we have launched our overlord and we set a real-time node going. The broker, several of these different Druid nodes have their own RESTful APIs, and the broker has one which basically will show you all of the data sources that you currently have. And I'm wondering if maybe this would be a good time to just pull up my example. If you can hold on for a minute, I'll just start getting that ready, because I do have this running on EC2. overs. Let's go back to that. Basically, only 2 ports need to be open on the EC2. One is 8080, which allows you to get to the broker. Typically, by default, the overlord goes to port 8087. I think I could have opened that too, but I didn't do it, so I probably won't do it tonight. And of course, you need to SSH into it also. So here are a few more items in the RESTful API. So the first one out there is basically an ability to just query Druid. So you see for the port number, I've got either broker, real-time, or historical port. What that means is basically any query that you can make to Druid, you can make to any of those. If you make a query to the broker directly, it will go out and look at the historical nodes and look at the real-time nodes, and even if your query spans both periods, it will merge them together and give you a result. Although, if you want to just query the real-time data, you can do that by hitting the real-time node. The second item up here is how you post a request to start a task on the overlord. So, for example, where it says task file there, that might be a specification for doing a batch ingest of data. And then there are a couple other URIs available for doing status and shutting down tasks. Quickly in batch ingest, there's 2 different ways to do this. So in the old way, which was called the Hadoop Druid indexer main, as you can guess, you're probably expected to use Hadoop to do this. And if you had a Hadoop cluster, you could point Druid at the Hadoop cluster and use that to do your batch ingest. If you didn't actually have a Hadoop cluster, you could just fail to specify it, and Druid would launch a small Hadoop, quote-unquote, cluster for you. That was a little bit of a problem because it only launches a single reducer per segment. And so, just to explain why that's bad, if you are loading a day's worth of data at one time in a batch job, and your segment granularity is 1 hour, that means you would need 24 reducers in MapReduce to load that, and it would just crash when I hit the request for the second reducer. So that old Hadoop Druid indexer main is still available. It's available here under Hadoop index. So basically, you can still, under the new indexing service, you can still do a Hadoop batch, and it still operates the same way as before, meaning that you don't actually need a Hadoop deployment, but you're a little limited if you do that. The simple index service, which we're going to see tonight, doesn't need a Hadoop deployment. It's just designed for smaller tasks. So I was joking with somebody earlier today where they said, they say most big data projects involve like 16 gigs of data, And so I decided I'm going to do 400 megs tonight. So there's a lot of temporary storage during a batch job. Some of that's internal to Druid. Some of it's internal to Hadoop if you're using the Hadoop indexer. It's pretty easy to run out of disk during an ingest, and redirecting the temp output can be tricky. So for example, if you're using the Hadoop Druid indexer, obviously it's going to spawn a Hadoop MapReduce process, and you have to be pretty careful to make sure that that process isn't going to also write to /temp. I've spent so much time on this, I can't believe it, but it's just kind of the way it is. Once you have one process spawning another, and another, eventually gets to the point where that poor guy down on the bottom doesn't know where he's supposed to put anything. And I think that's kind of what happened here. Druid has this special property prefix you can do. So